I'm gonna tell you a bit about this library called PyJSX that I wrote, which essentially allows you to mix Python with HTML, or more specifically with JSX, in a single file seamlessly. So just a bit about me. So I work as a software engineer at CERN on some cool open source projects. You may have seen the presentation in the morning. And I'm also the latest EuroPython core developer, actually, since last month. I mostly, yeah. Thanks. Yeah, I mostly help out with the JIT and also do some work on internationalization and the new REPL as well. But back to the talk, also a disclaimer. So PyJSX is just a project that I made in my own free time. It's definitely not production ready, so just take it for what it is. And yeah, so what is this all about? So writing JSX in Python, what does this mean? So for those of you who don't know what JSX is, here's a quick recap. So JSX is this feature of React which basically allows you to mix HTML with some JavaScript code. So this is a very simple example. You have this JavaScript function that returns some HTML. And this HTML is treated as like a normal, regular expression in JavaScript. It can also take some parameters. For example, the name here is a parameter that gets kind of interpolated into it. So another disclaimer, so JSX is not React. There are a lot more things to React than just JSX. For example, state management, syncing with the DOM, and a lot of other things. And so when I talk about PyJSX, I really just mean the templating part. I'm not talking about re-implementing React in Python. That would be crazy. So yeah, so if JavaScript has this awesome declarative way to create HTML, why not Python? That's basically the question behind PyJSX. So here's a quick demo of what you can do with PyJSX. So this is a very super simple file. It's called hello.px. So use the px extension to kind of distinguish from a regular Python file. And I'm just defining a variable, and I'm assigning some HTML elements to it. To make this actually runnable, I need one more Python file where I do some initial setup, and then I just import this other file. I import the variable, and then I'm just going to print it. So when I run this, again, as a regular Python file, I'm actually going to get the output that I'm expecting. So I'm just going to get some HTML out of it. So that's a very simple example, but you can, of course, go crazy. You can do more things. So this is a more involved example. So for example, you can have this user card component / function, which returns some information about a user, for instance, for example, a name and age. And then you can have this app function or a component that just renders all of the users. And so, for example, I'm not sure if you can all see it, but the line at the bottom with the braces, so what's inside, that's just a normal Python generator expression in it. So it's just regular Python. So I'm not the first one to have had this idea. So there have been many libraries before that kind of did very similar things. So for example, one called Pixel from Dropbox, but there have been quite a bit more as well. So, of course, I made this thing pretty much last year, and I was kind of proud of it, so I wanted to share it. So I went to r/Python on Reddit, and I posted about the library there, which I now realize was a big mistake. So, yeah, some people, I don't know if you can see the comments, but I will read some of them. So some people weren't really convinced. So, very cool project, very bad idea in practice. Please no. All right. Some people are just a bit confused. So, wait a minute. It's not strings, it's a new syntax. Yes, it's new syntax. And some people just, yeah. This is so much overhead that my head might explode. And why does it feel like we spent the last 30 years trying to go back to writing HTML directly? So yeah, lesson for next time, never share anything on Reddit because, yeah. Anyway, yeah, so what's the motivation for a project like this to actually exist in Python? So imagine you are trying to render some HTML. So what are the options you actually have? If you are crazy, you can build up HTML just by concatenating some strings, right? That works. But good luck trying to make sure that the HTML is actually valid, that you didn't forget to close all your tags, and that you don't get any HTML injection, and that you escaped all of the characters that you need to escape, right? So this in principle works, but nobody really wants to do that. There are actually some other libraries that kind of help with this. So for example, there is a library called htpy that kind of simplifies the creation of HTML using this kind of trick with this, list subscription with the square brackets, which works, but again, it's not really HTML. It's a bit more hard to read. So, and there's of course Jinja, right? Which is probably the best thing we have right now. We can write very nice declarative HTML, and then there's some extra syntax to kind of manage the whole thing. My problem with Jinja is that it's not Python. I like writing Python, and I don't necessarily want to, write Jinja. I don't necessarily like the Jinja syntax and the way they do things, like template inheritance and a lot of other things in there. So what I would like to keep is like all the declarative way to write HTML, and just replace all of the Jinja syntax with normal Python, which is basically what PyJSX does. So hopefully I have kind of managed to at least convince you that this is not a complete heresy and that it might be useful in some situations. And now for the second part of the talk, I wanted to spend some time on the implementation, which I think is quite interesting. So there are basically two main parts to it. There's a bit of import magic that basically allows me to import .px files directly from Python, which you normally cannot do. And then there's the other part, which is just transpilation, so turning the PyJSX source code into something that is runnable directly by Python. So let's have a look at the import magic. So going back to the first example that I showed, let me just highlight the part that is relevant. So this import, so this doesn't actually import anything. The only point of this is to register a new import hook with Python so that we can import .px files. The way it works, basically we have this import machinery in Python, and the TLDR for that is basically Python allows you to import literally anything, but you have to tell it exactly how to do it, right? So to give you an example, let's say you have this data.json file with some JSON inside, and, well, I can have this script where I basically change this sys.metapath special variable. I append something called this JSON finder, which I will show on the next slide, so don't worry about it too much. But what this allows me to do, I can then say from data import JSON, and when I actually print it, I'm gonna get the actual JSON contents of the JSON file as a Python object. So if you don't like JSON.load, you can use this, right? And this is like a very crude implementation of the JSON finder. And I use basically the same thing to load the PX files directly from Python. So I have this PyJSX finder and loader that do essentially the same thing. So this covers the part about the import magic. And now let's talk a bit about the transpilation, which is the second part. So basically, I have to take this PyJSX source code, which is not valid Python because there's all this HTML in it, and Python doesn't know how to run it, and I need to turn it into normal Python. So basically, we have this function, and we need to implement it. So we are, of course, engineers, and we are lazy, so we don't want to re-implement the whole Python parser, and tokenizer and everything. But it turns out we actually don't have to. We can actually let the Python interpreter do all the heavy lifting for us, and we just need to handle all the JSX parts, all the extra things that we are adding. And I'm going to show you how this is done. So there are basically three main stages to this. There's a tokenizer, there's a parser, and there's a compiler. The tokenizer is really simple. The only thing it really needs to do is just distinguish all the Python parts, like all the valid Python, from all the JSX parts. And then the parser just takes all the JSX pieces and puts it into some kind of syntax tree that then we can kind of process later in the compiler, where we just, again, take all the JSX pieces and turn it into some kind of native Python that we can run. And we just ignore all the other Python. We just pass it through as it is. So it's relatively simple. So let's start with the tokenizer. So again, a very simple piece of PyJSX source code. You have this variable. You are assigning some HTML to it. When you start tokenizing this, so the first two tokens is the greeting, the variable name, and then you have the equal sign. This is just normal Python. But if you keep going, you can see that now we get some tokens which are not regular Python tokens. So for example, the third one is this JSX open, which is the first angle bracket at the start. And there are also some other ones. So there's this JSX close, JSX text, and a lot of other ones as well. So this is all the extra stuff that we have in a tokenizer. Now, if you are wondering how we can actually distinguish at the tokenizer level all the JSX from Python, because an angle bracket is also a token in Python, it's actually very simple. The way we do that is if we see an angle bracket, if it follows any of these tokens / keywords, we know it's JSX. So to give you an example, if the tokenizer sees like a return keyword and then an angle bracket, basically no matter what you put after, it's never gonna be valid Python anymore. So we can just make the assumption that this has to be JSX. So for example, return and some HTML element. The same, for example, if you see like an open square bracket and then angle bracket, again, no matter what you put after, this is never gonna be valid Python. So we can just assume, this is PyJSX and parse it as such. So that's for the tokenizer. Now, the parser, again, we just need to parse all the JSX. We don't care about Python at all because we can offload this to the Python interpreter. So yeah, that's basically what I said. Yeah, so again, if we have this line of code, the parser basically produces something like this. So the greeting equals sign is basically kept as a string because we need to do any processing on it. We don't really care. If it's invalid, Python is gonna tell us, so we don't really care. And then the rest, it needs to have some kind of structure. So for example, there's a name. You can see the name equals B. So we know that it's the B element, the B tag. And then there's the children. The children is just the children of the HTML element, which is hello EuroPython. And then there is the compiler. So that's the last stage. Again, we have this line of code. This is what the parser gives us. And then the compiler just produces this line at the bottom. So this is just kind of some function call which just passes the arguments to it. And this JSX function is basically responsible for actually constructing the HTML. So what you write as a developer is the first line, and what PyJSX does, it just turns that into the thing at the bottom. And I haven't showed yet what this JSX function, how it's actually implemented, but it's actually quite simple. So this is one example how you could do it. It's just some kind of, again, you just take the name. Now there is some string manipulation here, but it's only in this one function, so it's fine. And we can kind of, do the proper escaping in here, and everything is just hidden in the library, so it's fine. So just to recap, we have these basically 3 stages. We don't do a lot of work because we can offload most of the parsing to Python. We just need to kind of pick out all the JSX, do some pre-processing, actually make sure that it's valid. And then that's it. We write the regular Python, and then we just execute it. So that's how it works. And now for future work. So I have basically, what I showed you, most of that is working. What isn't really working now is if you open the source file in your favorite editor, it's just not gonna, well, you're not gonna get like syntax highlighting, you're not gonna get diagnostics, you're not gonna get linting, you're not gonna get formatting because the editor doesn't know what this thing is, right? So it would be really nice to have some kind of language server for this. So my idea is basically to take some other open source language server for Python, like Rav or Pyrite or something else, and write some kind of front end for it, which is just gonna take the PyJSX source code, it's gonna convert it into Python, it's gonna give it to this other language server, it's gonna collect the diagnostics, and then it's just gonna funnel it back to the editor. And so that way, we can kind of avoid re-implementing the wheel, but we still get all the useful stuff for PyJSX as well. All right, yeah, and if you'd like to help out with any of this, there's a lot of work to be done, so yeah, reach out to me wherever you want, and yeah, that's all I have.
Thank you so much. That was pretty interesting. Do we have any questions from the audience? You can I can hand you the mic, or you can line over there.
Can you show the example with where you use a mix of JavaScript dictionary a kind of explosion with Python. So like with the for loop of user that you use
Yep.
dot user.
Yeah. One sec. Up. That's before this one.
No. Also this, of course, but there was also the one which expanded the user variable, like when you did the for loop.
Yep. Yeah. This is like the first example. This one.
Yeah. So like here, so anything that is in those JSX start and end things, that would just be pure JavaScript. So
It's not. So this is not. If you're referring to like the 3 dots, this is the JSX specification. So JSX as a language is specified, and this is like the spread operator, which is part of the language spec of JSX, not JavaScript. So I'm just like re-implementing JSX as it is specified.
Okay, so like it's that specific line is using a mix of both languages in a way. That's
yeah,
nice.
I mean, that's what you use in JavaScript, but this is separately defined in like the JSX language spec as well, right? You could use actually like 2 stars, I think, like the Python syntax as well, but I just wanted to stay consistent with the official spec for JSX, right? But this is just one thing from there. Like you can put any other Python expression inside the braces.
Okay.
So yeah, it's just regular Python.
Okay.
Does it work with Wasm, so like Pyodite and PyScript?
I haven't tried yet, so I don't know. It's just pure Python, so I assume it does.
Thanks. I find this a very fascinating concept. Question, you mentioned like the JSX starts after certain tokens, and I noticed the arrow token there as well, which is generally used for like function typing, like return statement typing. Do you have any plans to do something with JSX there?
No, it's just, I think, for a completeness sake, because after like the dash arrow thing, like in type annotations, you can put any Python expression in there.
Right.
And I wanted the JSX expressions to be basically treated on the same syntactic level as other Python expressions.
All right, okay, cool. Thanks.
Thank you for a very interesting talk. I'm really interested in this kind of thing, and I just talked with a guy who maintains some Python library that maintains some virtual DOM thing or things like that. So I'm curious about this JSX library has some future possibility to collaborate with this kind of such kind of a project to make it possible, for example, like to do server-side rendering that is, for example, like what Next.js is currently doing, or things like that?
Yeah, this is pretty much like server-side rendering. So you are just rendering HTML in Python. Then you can plug it into whatever web framework like Flask or whatever else you want. This is just about constructing HTML in a nice way. So kind of like Jinja, just without Jinja. So
well, like just rendering a very first snapshot of HTML, just kind of trivial. But like, do you have any idea of partial hydration or what kind of a thing like that?
That's not really something I have considered yet, to be honest. So it's still like very early stages. So no.
Thank you very much. I'm really like
Thank you.
I also have a question about can we import .jsx files like directly? So if I have a React app running, I can just reuse files between React and this. So is that possible?
Yeah, of course. With the import hook, you can import any like this .px file from anywhere, because you just register the import hook, and now Python knows actually how to import those files. So you can find them, and when you import them, you just do the transpilation, so that when you are executing the code, it's just normal Python. So you can that's what I showed. You can import these files from anywhere. So you can mix Python and like PX all together, and it's gonna work as long as you register the import hook before you do any sort of imports.
Cool. Thanks.
I have another question. I guess debugging PDB doesn't work on this.
Sorry, could you
I
repeat
guess
that?
debugging PDB doesn't really work with this yet or at all?
Yeah, probably not. I was thinking I could have some kind of command line maybe tool to kind of transpile the files into Python so that then you could run it and then you could put like a breakpoint. But now, currently, no, it doesn't really work. But yeah, contributions welcome.
So, I mean, since the other guy mentioned something about server-side rendering, I think an interesting use case for it could actually be if you want to reuse the same JSX both for like Python level server-side rendering, but also then with normal React when updating things live. Of course, there's slight syntax differences, but have you considered, for example, writing a bubble plugin for JavaScript that can take Python syntax and rewrites it to normal React components? So you could basically import the PX file in JavaScript to have the React components there?
No, I have not considered that. But might be a good idea.
Yeah, because that could be super useful for something like Indica.
Yeah.
So I would like to ask, for example, I know it's right now hobby project, but if somebody takes it and, I don't know, build 200, 300 components, like a big component tree, like where is the heavy load happens? Like when all this transpile, compile thing happens, it's one time per application start.
It happens at imports time, and imports in Python are cached, so it only happens once. Basically, if you import the same module twice, it's already cached, so you only pay the price for the transpilation once it's the first time you import the file.
And then it just runs like the functions that are...
exactly. Yeah.
Super. And I have the second question is one of the questions that was on the Reddit, why not strings? Because I kind of did similar exercise for my hobby project, and I use strings. I'm just thinking like you don't use them, and then you pay the price to transpile a specific file to the Python code, and then code editor and everything. On the other side, if you would use strings and, for example, decorate all the methods with, I don't know, add components that will add additional magic, you will already have built in all the DX from all the editors and so on. So what was the idea here?
Yeah, for sure. Like the upfront cost is much higher for this, but I think the end result, if we actually get some kind of language server or something like that, the DX at the end is gonna be much better, because just with strings, for example, you cannot like validate that the HTML is valid at import time. You only figure out at runtime if it's valid or not, right? With this, I know when I try to import something and I forget like a closing tag or something, I know when I try to import the module that it's invalid, for example. So that's one of the things. And for example, syntax highlighting is another thing. You will never get it with strings. And yeah, actually I have this VS Code plugin which actually adds syntax highlighting for this thing and some other things. I just need to publish it, but it's kind of like work in progress. But I was hoping to do it before the conference, but maybe I'll do it during the sprints. But yeah, so for example, for VS Code, hopefully when, like this weekend, when you open this file in VS Code, you will get all the syntax highlighting. You can also toggle comments, stuff like that. So it's, on the way there. And yeah, for me, like this is much better than strings. I don't want to deal with strings. Yeah.
Thank you very much. And don't leave it at the hobby project.
Thanks.
Yeah, I'd like to second it. I think it's a really great project. And in fact, I was wondering, could you see yourself maybe writing a PEP for this to adopt this into the... you can imagine something like the T tags, right? Where we just return the JSX, not even the rendering, just the JSX object, and then various libraries could do with it what they want.
Well, seeing the, let's say, the responses on Reddit, I don't know if I want to go through it one more time. So yeah, I don't know, maybe at some point if like this gets more popular and more people use it, maybe, yeah.
So Sydney already also mentioned the T tag, like template strings.
Yeah.
If they have been available like a year ago, would they have influenced your project in some way?
I was expecting a question about that. So yeah, again, like T strings are cool because you can do this sort of thing much. It's easier to implement. You don't need all this like import magic and all of this. But again, I think the DX there would still not be, at least in my view, good enough because T strings are still just strings. So you don't get syntax highlighting, You don't get any sort of like import time validation that is correct. Again, it would just be, you would figure out at runtime that maybe, you're missing a tag or something. So again, if you want something like this, it would be much easier to implement, but the end game for me just isn't there, I think.
All right, thanks.
Again, me. I'm curious about with the current implementation, what does it look like if there is some syntax error? Is it easy for the developer to debug some syntax error because it has some technique on ASD or things like that?
So I try to have like helpful error messages in the parser now. So you get like the line and the character where the error is. It tells you it's like a normal syntax error in Python. It looks a bit like that. So hopefully helpful enough for people to figure out where the problem is.
So for example, like if there's some syntax error just inside JSX part, what happens?
It just raises like a parse error or something, just like maybe even a syntax error. Just like when you have a syntax error in regular Python, it's just gonna raise and it's gonna tell on this line, on this offset, there's an error and there's some kind of error message. I don't know exactly how many error messages or how I try to make the error messages helpful, but yeah, it's basically like normal Python syntax errors. It looks the same way.
Thank you.
Great project, great idea. I wanted to ask, for example, I have a couple of JSX files. How hard will it be to migrate them to Python?
Well, so as I said before, I followed the JSX spec. So all the JSX that you see is the same. The thing is that's different is inside the braces, because inside the braces you have Python syntax. You can put any Python expression inside of the brace, right? So, and if you have JSX files, you probably have some JavaScript inside those braces. So you don't need to convert the JSX, but you need to convert the JavaScript expressions into Python.
Okay, so like semi-automated way could be, or maybe some AI tool.
Yeah, maybe.
Thanks.
Maybe.
Thank you. Do we have any more questions? Maybe time for one more? No? All clear? Okay, thank you so much once more time. Thank you.